Hello everybody and welcome to the first devlog video for the Detectorist Guild. So we'll jump straight in and have a look at what it is I actually want to kind of show you today. I first just arrange my window so I can see what I'm doing. So the main thing I want to look at today is the scanning mechanism. So this is the initial draft for it. So we have an inventory scroll-based system. If I scroll with my mouse wheel left and right or up and down with the mouse wheel, then I can activate and switch between this mode of placing markers, which we'll get to, using the metal detector and then digging. So we'll just go through the scanner. So the first thing is to make sure that the scan is in its active state. Now the movement system is still based on this third-person template. So wherever I point and click, the mannequin will walk in the appropriate direction. So here it's basically just following my mouse around. So what all that is happening is when the character walks over the required area, you can see we have a little print screen in the top left, which is to identify that the player is standing in the correct place and that they have scanned the item. So the item is underneath them and then they can dig it out. So that's all we want going to actually look at, but there are three different things to cover. Just looking at the top of this bar here to explain how this all works. So the first two, quickly to get out of the way, you've got the structure for the finds and then the data table for the find. So basically find is my word that I'm using for anything which is hidden under the earth. We could call it artifacts or whatever we want, but I've decided on finds. So if I just created the structure first, obviously before I could fill in the data table, at this point there's not a great deal of data in there. This is something which is going to be expanded upon at a later date, but at the moment we just have the coordinate, so the XY location, which will be applied to every artifact. So that's just a vector 2 object. So all I've done is add two variables. The first one, the coordinate location, as you can see, and obviously it's 2D, so it's just going to be XY coordinates, and then the item name, so something which we can print to let us know that we are correctly standing over it and that the basics of this scanning system, this metal detecting system, is actually working. So with the structure in place, that means we can then actually put the information we need into the data table. Obviously this is easily expandable, but we've just got two items in here at the moment. So no detail or specifics. We're not trying to tidy everything up at this point even slightly. We've just got two placeholder names, cheese and muffin, and then based on their coordinate location, so for each item there I can add the name in, I can add the XY location information here. So you can see at 800X and 1900Y is where muffin is located. So with that data, we then need to find a way of getting that basically kind of into the gameplay. So these are all the bits of blueprint code which are making this system work. So if I start from top to bottom, so the first thing, as you can imagine, is what is going to happen on the start. So the opening of this interface. So it's an inventory widget where I'm putting an awful lot of my code. It's very proof of concept. So if I scroll down here, you can see I've not neatly organized everything into functions yet. It's basically just very proof of concept and a wee bit messy. So I've tied it up as much as I possibly can, but it could be an awful lot tidier than this, I'm sure. But just to draw your attention to the main things which are going to happen at the beginning, and the only thing we really need to pay attention to is this create find structure. There are other things that are going to be happening, but it's the create find structure. So that's something which needs to happen immediately. In terms of what that create find structure function actually is, it's what we've got here. So as you can imagine, because we started off with a data table, we need to basically get that data into some format which will be workable within our widget blueprint. So I've just got the get data table row names, and then it will cycle through every single. So if I just open that back up again, go to the data table. So obviously there's only two, but however many hours to add into this for each loop, it would just go through all of them individually. And then it would get that data because we've got the get data table row names, and then it will loop through those. And then in the finds data table function that we've got here, so for each one, so however many items I put in the finds data table, obviously there's only two, so it will only do this twice, but it will, based on that row name, it will get the relevant information out, and it will add that as a separate variable within this array that I've created. So you've got finds undiscovered. If I just scroll that out a little bit, you can see we've got finds undiscovered as a structure, which is an array of structures. and then finds discovered as a structure, which again, also an array of structures. But basically what we need to do is kind of compile that list of all the different artifacts, all these finds that are hidden underneath the earth, that if the player goes over whilst in scanning mode, they will reveal themselves. So that's to create that initial structure. And that then takes us to the second part. So once we've got that in place, it's then about, actually having the scan functionality working. So the way that I've decided to do this is based off on a tick. So everything which is in this line of code is happening all the time. Obviously, it's only happening if the scan function is activated. We'll come back to that in a second. But we're using an event tick to basically, every frame be checking where the player is and be checking whether they're in a location which is close enough to the artifact for it to detect as a hit. Which we can then add the later functionality where the player, once they've identified where the item is, that they can scan it more accurately and then they can dig it up. So that detector scanning code is everything we've got going from left to right. So every frame, it's checking whether we're in scanning mode. That's something which is a little bit separate, but just very, very quickly. That's over here. It's related to the scroll items code. I won't go through all of this here, and it's relatively generic anyway, so I don't really want to waste anybody's time with that. But if we go through, the idea is it's just whenever the scroll input or output is changed, then it's checking what this selected slot we're in. So unless it is, as you can see, so if we go into the actual game itself, so if we were here, we've got the marker mode activated. If I go over the top, nothing happens. If I was to go into that needs tidying. If we go over here and have the digging mode, it's not going to detect anything. But if I'm in scanning mode, then I'm standing in the right place. Then it's detecting that I'm standing over the muffin. So that's quite useful because it means we've not got all of this code, bearing in mind there's a loop within this happening all the time. Because we want to try and optimize things as much as we possibly can, even at a prototype stage. So to just go left to right. So we've started off with a frame tick checking whether we're in scanning. Presuming we are in scanning mode, it's then going through. The first thing is I've included a detector delay. So the intention here is, one, to kind of optimize the system a little bit. So obviously every frame is going to be, an awful lot of routines, that's going to go through an awful lot per second. Whereas if we put some kind of delay on, then depending on what that delay is, that's only going to happen, once every whatever that, X amount of time. So I've set that as 1. So that does create this kind of situation where if you walk over it, but you walk over the item too quickly, then you will miss it, which is a design feature. That is kind of the intention, that you need to kind of, ultimately, we're going to have walking speed and other elements that are incorporated here, where there is the potential to miss an item, even though you've technically just walked over where it is. You need to be careful with your metal detector technique, which is just like it is in the real world. You can't just run across the field. You've got to take your time, and you've got to be slow and steady. This is also something where that could become a modifiable variable at a later date, depending on what kind of detector you buy, or upgrades, or various things like that. So that variable could be something that we could adjust based on the type of detector that the player has got at any one point. So maybe an upgraded detector would have a lower value than 1. But the idea is we've got this kind of optimizing delay here, which is just calling all of this once per second. So as I say, there is that risk of them wandering over the space and missing it if they're not careful. But for every second, we then go through this stage, which is pretty much the comparison process, where we're looking to get the world location of the player. We're looking to compare that to the coordinate location of all of the finds which we've got in the undiscovered array structure, or structure array, I should probably say. And if there is a hit, then it will just print the name of the hit. So if I was to walk over something and I was in the correct coordinates for cheese, it would say cheese. And if I'm walking over the correct one for muffin, as it is here, then we would get muffin. So in order to get the player, we're, as you can imagine, just starting off with the get player character. And I'm going off the position of the mesh of the player character. That then gives me, I can then pull out from that and get the get world location. Of course, because I don't want the XYZ, I'm breaking that down, separating out the X and Y, discarding the Z, we don't need that, and then building that into setting the current vector. So every second we get the current 2D vector of where the player is, and then once we have that, we check it against all of the coordinates which are placed within that finds data table. So the more that I add, the more that's going to have to chug away, which is another reason why if that list gets particularly big, we're going to need ways of making sure this is kept optimized, because kind of looping significant chunks of data, every frame is not going to be particularly efficient. What sort of effect it will have on the on a half decent PC these days, it's difficult to tell, but probably better safe than sorry. So that then there's only one other thing to talk about here, which is detector range. So as you can see, we've got the location of the player. We then loop through every single find which has been created in that structure array. Obviously that structure array was created here at the beginning when the inventory was opened. So it loops through all of those and it compares the current player 2D vector against the target location of that particular artifact, but then I'm using a nearly equals or an equals that's got a particular error tolerance. Again, this is similar to the detector delay. It's something which I'm thinking at a later date is something which could be adapted depending on kind of what sort of metal detector that you've got, because again, true to real life, different metal detectors have different ranges. More expensive ones do tend to have a wider or a deeper scanning range, so there is a greater margin of error with a more expensive metal detector. So here we've got an error, just like I said, this is just a placeholder for now, but an error value of 30. So if there's a difference of 30 units or less between the coordinate location and the finds undiscovered, and the current 2D vector of the player, then it will still tick. Obviously, if that detector range was 0, it had to be absolutely equal. Bearing in mind we are dealing with pretty precise float values, it would be borderline impossible for you to find anything at all. So there obviously needs to be some kind of margin of error, hence why we're using this particular node here that's got the error tolerance, but exactly what that error tolerance needs to be. I did a little bit of trial and error to arrive at 30. I think it could be a little bit higher, I think it could be a little bit lower, but that's something which we could explore when we expand into different detector groups. So just to return, we make sure that we're in scan mode, follow along the player. I mean, I think just to test it out, if I actually ran all the way across, no, it still picked it up, but it didn't that time. So if you just run mindlessly across, I've picked it up a couple of times, but there's a good chance that you will miss it. So the best practice is to be nice and slow and steady. You can't miss it there. It's just going to kind of repeat tick, and then we can move on to the next stage of deeper levels of scanning or more precise forms of scanning in order to identify it, and then hopefully digging the artifact out of the ground, which is something which hopefully you'll get to see how that works in a later video. That's everything for that one. I hope that was useful. I don't know whether any of these I tend to find when it comes to a lot of this learning how blueprints or any game coding, game development kind of works, being able to put something in a specific context just as an example to go, oh, that's what this might be useful for, can sometimes be helpful. I hope this was helpful to you. If there are any particular elements which you think could be made clearer, if you have any comments or anything like that, do feel free to leave those in the chat. But hopefully you'll join me for the next video when we'll explore this scanning mechanism to a greater level of detail. Thanks very much. Bye.